Trig functions, you'll recall, have inverses, and they're a little bit different than working with just other inverses. So we're going to treat their derivatives separately and work on those. Remember, if you have a function y equals sine of x, then this inverse, remember we switch the x and y's to find inverses, and then to solve for y we have this inverse function, this inverse trig function. Y equals the inverse sine of x. Now remember, when you do inverses, you need the function to be 1 to 1 in order for you to have a function that's an inverse. And so sine looks like this. It keeps going on and on. Remember, it's not 1 to 1. So we have to limit our domain of the sine function to be able to get the inverse. On page 47, there's a table that gives you all those limited domains that cosine, the inverse cosine only goes where x is between -1 and 1, your range is between 0 and pi, and so on and so forth. There's a yellow box there on page 47. You need to know that, and you need to put it in your spiral 3x5s that you're using to study for the exam, so that you know where you're limiting your domain for these inverse trig functions. Now, how do these work? Well, we have our limited domain, and we know what we know about the regular trig functions, and we're going to use all that stuff to help us find these inverses. Now, one thing you need to know is for the inverse trig functions, if your original function is, or for any inverses, if your original function is differentiable on an interval, whatever interval we're working with, and the derivative of that original function is not equal to 0 on that interval, then your inverse is also differentiable on that interval. Now, why does that make sense? Well, if you think about an inverse, if we've got, let's just say, an inverse sine. If that's sine, just from -pi/2 to pi/2, then remember, to get an inverse graphically, what you're doing is you're taking the inverse, you're flipping it over this y equals x line. So you end up with something that looks kind of like that. Okay, so when you're looking at this, if you see here, if you've got a place, for example, where your derivative equals 0, then your inverse is going to have an undefined derivative. So it wouldn't be differentiable. That's why you actually limit it from here to here, so that you have a function and so that you're also differentiable. So just think about, remember what an inverse is and how it works graphically and algebraically, and make sure that you can see why the derivative being 0 of the original function would be a problem for the inverse. Alright, so let's look at these. Let's say we have the inverse sine of x as our function. Now, we know that our y has to be between -pi/2 and pi/2, and our x is between -1 and 1. This is from that chart on page 47. Like I said, make sure you know that. So if we want to find the derivative of this, what we can do is we can start by using what we knew with our trig. What this says is x is equal to the sine of y. So if we take the derivative of this implicitly, then we'll be able to find the derivative of the inverse function. So derivative of x is 1, the derivative of sine is the cosine, and we have to use our chain rule because we've got this y as a function of x. So we have to multiply it times dy dx. So what that means is dy dx is equal to 1 over the cosine of y. Now, the cosine of y is positive in this case because of where we are. We're in the fourth or the first quadrants, which means your cosine of y is positive. So we can use that cosine of y is equal to the square root of 1 minus sine squared y. Now, do I expect you to have just come up with the fact that we need to do that? No, I'm deriving the formula for you right now, so just think about it and make sure you understand how I got this. Now, the thing about this is we know that 1 minus sine squared y, well, what's sine of y here? We're using it as our x. So it's over the square root of 1 minus x squared. Now your x, the absolute value of x, has to be less than 1 because of this right here. But this just gives you the formula. Now, I've derived this formula for you. Do I expect you to derive the formula for over and over? No, absolutely not. So I'm going to give you the formulas for these inverse trig functions so that you'll have them. You need to write them in your spiral, and you need to be able to use them, so you're going to have to memorize them pretty well. Now remember, we've talked about chain rule, and if we take the derivative, we just derived this with an x here, but if we had a function inside there, then we would just multiply it times the derivative of that function inside using the chain rule. The inverse cosine you can derive in a very similar way using the fact that sine is 1 minus cosine, or sine squared is 1 minus cosine squared, and you'll get this answer. And in your homework one day you're going to do one where you can relate these two together to help you see how they're derived. So look at these and notice they're very similar, except the sine is positive and the cosine is negative. Now the tangent and cotangent also go together. The inverse tangent, the derivative of that is 1 over 1 plus u squared, of course, times du dx, and then the cotangent, the inverse cotangent, same type of thing, except this time it's negative. And then the secant and the cosecant go together as well. Now, I just quickly derived one of these for you. We're not going to derive all of these. These are just formulas that you're going to have to use. You can derive them all on your own if you want, using trig identities, or you could go all the way back to the limits and things, but that would be really, really beyond the scope of what we've dealt with. So these are the kind of things that you're just going to have to memorize. But notice, all of these are in pairs, and the co ones have a negative 1 in the top, and the ones without the co in front of them have a positive 1. And then you just have to know what goes in the bottom and which pairs go together. So really you only have to memorize the pairs and know that the one without the co is a positive 1 in the top, and the one with the co is a negative 1 in the top. And that'll get you your Functions. You have to put these in your spirals for your 3x5s for your studying. You've got to know these. You're going to have to be able to deal with them. On page 161, there's some other identities that you need to deal with so that you can be able to go back and forth between these, and it shows you, and we're going to use some of those, the inverse function, inverse cofunction identities, the first box there on page 161 will help, but the calculator conversion identities, the second yellow box on page 161, will help a lot because you've got your inverse secant of x. Well, you know, when we just have secant, we just put it in our calculator 1 over cosine, but you can't do that with an inverse function, so you've got to know that instead you're going to put it in the inverse cosine of 1 over x, and cotangent of x you're going to put in pi over 2 minus the inverse tangent of x, and cosecant, the inverse, you're going to put in the inverse sine of 1 over x. And these you can also derive, but you just need to know these so that you can put them in your calculator, because otherwise it'll be very difficult for you when you need to use the calculator on these, because like I say, we will when we use the calculator a lot. The biggest thing in this section is to make sure that you know the derivatives of the inverse functions, of those inverse trig functions, and remind yourself just of what an inverse is, what that means graphically, what that means algebraically. So go back over those ones that I wrote out for you and write them out a couple of times and read over this section, page in 3.8, and make sure you've taken some notes on the yellow boxes, those identities there on page 161. And we'll go over how to work some of these in class.